I'm Michael Rossmann. I'm a General Manager of company Mirosys, located in Germany, and we have a close technical relationship with company Rohde & Schwarz. We are supplying customized solutions.
Great. Can you tell us about why the solutions you're showing today are so important to the automotive industry?
Definitively. We are here demonstrating a automotive radar target simulator. Let me quickly explain. Nowadays, it's a matter of fact that almost every vehicle, like car, truck, should have a special radar sensor for collision detection in the near future. Currently, the production of those radar sensors is ramping up very, very fast. And it's very important that for production of radar sensors, the testing time keeps to a short amount of time. We have developed a special automotive radar target simulator. This is a novel instrument that is digitizing the incoming radar signals, adding important information like distance, velocity, and object size, sending it back to the radar sensor, and therefore in the production field you can quickly test in the range of a few milliseconds the entire performance of a radar sensor.
Okay, perfect. And this is a real-time solution. Can you show us what we're able to test and monitor?
It's definitely a full real-time solution. Here on the show we have the following simple setup. On the roof you see a commercial available radar sensor. This radar sensor is transmitting its signal into the antenna. Antenna is connected to the ITS 9510A automotive radar target simulator. The signal inside is digitized, and in the digital domain we are changing distance, we are changing velocity and changing object size, sending then the signal back, and here you see the current output of the radar under test. Here for this exhibition we have set the instrument doing a ramp starting at 100 meters, stopping at 200 meters. And here you see at the distance display that the distance is increasing. Currently 177, it goes up to 200 meters, and due to our settings here, when we have reached 200 meters, it quickly jumps back to 100 meters. And now, sorry. It starts again at 100 meters. Okay, thank you. That's the short principle. Huh?
Thank you. Hi, can you tell us your name and who you're with and what your role is, please?
Well, my name is Herbert Schmidt. I'm product manager for signal and spectrum analyzers within Rohde & Schwarz, company based in Munich. And well, one of my products I'm responsible for is this FSW signal and spectrum analyzer.
Great. So I understand this part of the solution is aimed at the development organizations. So can you tell us a little bit about what you're showing and how the product works?
Okay. Well, it's correct. We have seen right now the target simulator, which aims at testing the complete sensor with everything in there, receiver, transmitter, and signal processing. But before you reach that state, you have to test all these components separately in development and to see how they are working correctly before you interface them together as a complete system. And here the FSW comes in. What we see here right now, we receive the same signal as our target simulator, and we analyze it here on the FSW, on the signal and spectrum analyzer. We capture a 500 megahertz wide signal, and in this case automatically detect the chirps in the signal, which is the waveform. We detect the chirp rate automatically, and then we know how the best signal should look like, and we can measure the differences between the ideal signal and the real signal, and we show the errors, like on this display. It should be a straight line. Any deviation from this straight line will show an error, and this will influence the accuracy and the resolution of the radar as such. That's the reason why this is an important tool during development for any kind of those radar sensors. And the tool itself is flexible enough to cope with many different waveforms, not only FM chirp, but also, for instance, FSK waveforms. So it complements ideally what we have with the target simulator. So both together are ideal tools to make the complete tests on and development of radar sensors.